everybody, Mr. Mack here. This section is going to be about golden ratio proofs, but before we get there, we need to review the quadratic formula because that is one of the tools we are going to use to come up with the golden ratio. So let's review it. Hopefully you've seen this in Algebra 1, and then even if you haven't, we'll teach it to you here. So the quadratic formula says that if we have an equation in standard form, like this, we've been talking about this standard form that we need for factoring, ax squared plus bx plus c equals 0, we can then use values for a, b, and c into this formula here, and it will tell us the two solutions to the quadratic equation. So here we have x squared minus 3x minus 28 equals 0. I'm going to solve by factoring and by using the quadratic formula. Okay, so it's already in standard form, and why don't we just take this and let's just first factor it. I gave you a couple here as we go through the first few problems that can be factorable, and we've got x squared minus 3x minus 28 equals 0, and we're going to break this up into two binomials, and we know the first term is going to be x and x for each binomial, and now we're looking at negative 28, and we need the factors of negative 28 that will add to negative 3, right? And so we can go through a whole list of those factors, but I hope you see that it is going to be x minus 7 and x plus 4. So negative 7 and 4 are the factors of negative 28 that add to negative 3. Now, if we use the multiplicative property of 0, what value of x gives us 0 in this quantity? Because 0 times anything is 0. If you're not sure, just set up each quantity equal to 0 and solve. So we get 7, and this one we get negative 4. So those are our answers. It's going to be 7 and negative 4. Okay, that was factoring. Let's take a look at the quadratic formula. So the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is derived from completing the square, and we're not going to look at that for this, but the proof for this equation does exist, and you'll see it in Algebra 2 most likely. Okay, so what do we have here? A is 1, it's a coefficient in front of x squared. B is negative 3, coefficient in front of our x term. And C is our constant, is negative 28, and we're going to put it in negative parentheses. Let's always use parentheses when substituting, especially with negative numbers. Negative 3 squared minus 4 times 1 times negative 28 all over 2 times 1. Okay, we got negative and negative 3's. 3 plus or minus. Okay, negative 3 squared is a positive 9. Negative 4 times negative 1 times a negative 28. So a negative times a positive times a negative is going to be plus. This is 112. All over 2. Okay, so we get 3 plus or minus 9 plus 112 is 121. The square root of 121 is 11. So we've got x equals 3 plus 11 over 2, or we have x equals 3 minus 11 over 2. 3 plus 11 is 14. 14 over 2 is 7. 3 minus 11 is negative 8. Negative 8 over 2 is negative 4. So we still get 7 and negative 4 by using the quadratic formula. Now the quadratic formula is more work, potentially, but it's going to work in every case, even with equations that are not easily factorable. Let's look at number 2. So as we look at number 2, I say, okay, factor and use the quadratic formula. So hopefully you see that this one is a level up from the one before, because we have a 2 here as the coefficient of x squared. So this is factorable, though. We're going to do our factor by grouping by multiplying 2 times negative 5, which is negative 10. Okay, we're multiplying our a term times our c term. And now we have to break the negative 10 up into two numbers that add to negative, two factors of negative 10 that add to negative 3. So the factors of negative 10 add to negative 3. Okay, so it's negative 5 and positive 2, right? So negative 5 times 2 is negative 10, and negative 5 plus 2 is negative 3. So let's rewrite our equation in standard form. So we have the 2x squared and we have the minus 5 at the end. This still equals 0. And instead of saying negative 3x, we're going to split that up into negative 5x plus 2x. So a negative 5x plus 2x would still give us the negative 3x, right? So now we're going to factor this by grouping. So what can I factor out of, we're looking at the first two terms here. So I'm looking at these two terms and these two terms. What is our greatest common factor? And it's just x, isn't it? So we got x, and we got 2x minus 5 for that one. And then 2x minus 5 here. There is no common factor, greatest common factor, so we're just going to leave it as 1. And we have 2x minus 5. And we see that in both of these expressions, 2x minus 5 can be factored out. If I factor 2x minus 5 out of that, I get x. Out of this, I get a plus 1. And now I use my multiplicative property of 0 to solve and I get 5 halves for that one, and this one I get negative 1. So these are my two solutions, 5 halves and negative 1. Okay, so let's take a look at solving this by using the quadratic formula. So we know that A is 2, B is negative 3, and C is negative 5. So 2, negative 3, negative 5. And my quadratic formula is x equals negative b plus or minus the square root b squared minus 4 times a times c over 2 times a. Now we're going to carefully substitute our values here. Okay. So negative and negative 3 is positive 3, plus or minus. Negative 3 squared is a positive 9. Negative 4 times 2 is negative 8 times negative 5 is 40 over 4. 3 plus or minus the square root of 49. 49 is a perfect square. We get 3 plus 7 over 4. Or we get x equals 3 minus 7 over 4. 3 plus 7 is 10 fourths, which is 5 halves. And negative 3, or 3 minus 7 is negative 4 over 4, which is negative 1. Oh, didn't write that well. Negative 1. Okay, so 5 halves and negative 1, just like what we got when we factored. Okay, let's take a look at the next one. Okay, solve. So I didn't say to factor this one. Hopefully you all see that the quadratic formula works. So for this one, let's just go straight to the quadratic formula. And we first need to put the equation in standard form. So ax squared plus bx plus c equals 0. And we need to identify a, b, and c so that we can then use the quadratic formula. So notice I'm just writing down everything I know, right? When you do a problem and it seems challenging and you're not sure what to do, just write down what you know, okay? These things you already know without even looking at the equation that you're trying to solve. All right, so this is not in standard form. So how about, we got 6x squared, we have a minus 2, minus 3x, and then let's add 8 to both sides. Okay, so we have this. Now what we want to do is let's add like terms and let's put this from the highest power to the lowest power. So there are no other x squared terms, so negative 6x squared. Let's write the x term next, and then I have negative 2 plus 8 is 6. All right. Next thing, we would rather have the leading coefficient here be positive, but we also want to simplify this as much as possible. So a negative 6, a negative 3, and a 6, I think we can divide everything out by a negative 3. Okay, negative 3 goes into all of these terms, and that gives me 2x squared plus x minus 2 equals 0. Okay, so A is 2. B is 1. Remember, there's a 1 in front of that x right there, and C is negative 2. And now we're going to put this in. So we've got negative, I'm going to put it in the quadratic formula. So x equals negative 1 plus or minus square root 1 squared minus 4 times 2 times negative 2 all over 2 times 2. Alright, zoom out a little bit there. So we got negative 1 plus or minus square root 1 squared is 1. Negative 4 times 2 is negative 8 times negative 2 is going to be 16 over 4. Negative 1 plus or minus the square root of 17 over 4. Okay, well, this is the solution right here. we cannot take the square root of 17. It's not a perfect square. That is how we leave this in radical form. This is the exact answer. Okay, moving on to number 4. Solve 3x squared plus x minus 5 equals 0. Find your answer rounded to the nearest thousandth. Okay, so we don't have to factor this one. In fact, this one is not factorable. So we're just going to go straight to the quadratic formula. So I'll write it down. Negative b plus or minus square root of b squared minus 4ac over 2a. It's already written in standard form, so we can identify a, b, and c. A is 3, b is 1, and c is negative 5. So we're just going to substitute everything into the quadratic formula and simplify. So we got negative 1 plus or minus 1 squared minus 4 times 3 times negative 5 over 2 times 3. Zoom in there. Okay, next line. One squared is 1. Okay, so we've got negative 4 times 3 times negative 5. So this is going to be a negative times a negative. This is going to be a positive. 4 times 3 is 12. 12 times 5 is 60. So this is going to be a plus 60. Over 2 times 3 is 6. Okay, so now last simplification here. 1 plus 60 is 61 over 6. So 61 is not a perfect square. So this is going to be an irrational number. It can't even be simplified, right? So we are going to use our calculator now. And we're going to do, so we want, in our calculator, let's think about this. In our calculator, we want to do parentheses negative 1 plus the square root of 61 divided by 6. Okay, that's going to be one answer. And the other one is going to be negative 1 minus the square root of 61 divided by 6. Be careful about your parentheses here. If you don't include them, you're just dividing the radical 61 by 6 and not the whole quantity negative 1 plus root 61 in this case. So parentheses, we've got negative 1 plus the square root of 61 divided by 6. Okay, and I get a preview here. I'm using the Web 2.0 scientific calculator, but you guys use your calculators. You don't need to use the online one. That looks good. Equals. So I want to work. Check your connection. Yeah, so let's reload this. Okay, 1.135. Whoops, let's get the right color for this one. So we've got x, yeah, that's not the right color. I'm using eggplant. X equals 1.135. 1.135. And then we're going to do it for the, so now I'm just going to go back up here and reload the original equation and just hit minus instead of plus. That looks good. Equals 1.468 1.83, so that goes to 8 because I wanted to do the thousandth place. 1.468. 1.468. Okay, those are my two solutions for this quadratic equation. Okay, so put it in standard form. It's already there. Write the quadratic formula. I would write this every time until you know it. List your values for A, B, and C. Substitute them carefully. Start to evaluate, simplify, and then when we get to this last step, we can go to the calculator if we're rounding. And I give you instructions to do so here. Let's do this one last one. We have 10x squared equals 6 plus 9x. Okay, first step, we need to get this into standard form. So I'm just going to rewrite let's just rewrite it. 10x squared equals 6 plus 9x. We're going to subtract 9x to both sides, and we're going to subtract 6 to both sides. And we get 10x squared minus 9x minus 6 equals 0. I have written this in descending order, the highest power to the lowest. And we can now write the quadratic formula. A is 10, B is negative 9, and C is negative 6. And, you know, this didn't simplify, right? So 10, negative 9, and negative 6 don't have any common factors, so I would have checked for that also, but there aren't any. And so now we're just going to substitute. So we got negative 9 plus, I think it's really important to use parentheses here because it's so easy to make a sign error. Same with this. Negative 9 squared minus 4 times 10 times negative 6 all over 2 times 10. Okay. Now, negative of a negative 9 becomes positive. Negative 9 squared is positive 81. Okay, a negative 4 times 10 is a negative 40, times a negative 6 is a positive 240. Over 2 times 10 is 20. All right, one more simplification here. Square root of 81 plus 240 is 321 over 20. Okay, and now we're ready to put into the calculator. So we get 9 plus, well, let's see, hold up. Let's use parentheses. 9 plus the square root of 321. 321. Where'd my parentheses go? Oh, I just erased it. Darn. 9 plus square root of 321. That's a bracket. I don't want a bracket. Second. I gotta hit the second button again. Okay, there we go. 9 plus the square root of 321 divided by 20. That's 21. 20. Okay, just checking here in the preview. I like it. Equals. Oh, darn. Okay. Internet connectivity is Got me working a little harder than I want to right now. It's all right. Okay, 9 plus square root of 320 divided by 20. There we go. 1.346. 1.3458, so that's a 6. 1.346. So let's put it over here. X equals 1.346, or we got to do 9 minus square root. 9 minus the square root of 321 over 20, and that is negative 0.4458, negative 0.446. Okay, that's your solution for this quadratic for number 5. Okay, tomorrow we'll do a couple more for our warm-up, and then we will tackle the algebraic and numerical definition of the golden ratio, and we will use what we have reviewed and learned to do that. All right, see y'all later.